Good day. For those of you who do not know me, my name is Douglas Harder, and in this first topic, we're going to introduce the course NE 112 Linear Algebra for Nanotechnology Engineering. So in this first topic, we're going to introduce this course and the undergraduate program in general. Now, to begin, I acknowledge that I live and work on the traditional territory of the Attawandaron, Anishinaabe, and the Haudenosaunee peoples. The University of Waterloo, as well as my home, is situated on the Haldimand Tract. This is land promised to the Six Nations of the Haudenosaunee people, that is, the Cayuga, Mohawk, Oneida, Onondaga, Seneca, and Tuscarora people. This includes 6 miles on either side of the Grand River. Now, first, welcome to your undergraduate program at the University of Waterloo. One thing that I've found that is absolutely amazing about the Nanoengineering undergraduate program is the incredible esprit de corps students have. It's much higher than in many other programs. Every year, the students in your program bond much more strongly than in other programs. You work together. It's just a friendlier environment. Hopefully, you will maintain this in the upcoming year, no matter how difficult it will be. So please, do try to keep this up, even if you are not seeing your peers on a daily basis. This is probably the most interesting and valuable characteristic of your program. It's absolutely fascinating how much this actually benefits you as students. You are nanotechnology engineering students, and you will do well. And when you graduate, you will succeed in this world. Now, in this course, well, here's the course description as in the undergraduate calendar. You can read this if you want, but most of it probably doesn't make that much sense at this point, so don't worry about it. Now, to begin with, for this course, all course material is available online at this website. Please bookmark this website, and this website will continue to be up long after you finish the course. So, whereas many other courses have their material on Learn, which you can only access for the duration of the course, all my course material is always available 24 hours a day to anyone in the world. Now, you will primarily be interested in 3 of the links on the left-hand side. The most important being the lecture materials link. Following this, there are assignments and projects. There's other material I provide as well. For example, a number of students in nanotechnology are worried that they've never been introduced to compiled programming languages like C++ and Java in their program. I provide this information for you, and I also, on my personal website, have an introduction to C++ for nanotechnology engineering students that you can review once you finish your course on Python. But you don't need any of this for this course. So what you're primarily interested in is the lecture materials, assignments, and projects. Now, the evaluations of this course will be as follows. There are 10 weekly assignments worth 20% altogether. There's a midterm examination worth 30% and a final examination worth 50%. All of these will be submitted on CrowdMark. The weekly assignments will be marked as follows. Each assignment is worth 2% of your final grade. Of that, 1% will be based on the correct completion of one randomly chosen question. The other 1% will be based on substantial completion of the balance of the assignment, regardless as to the correctness of the solutions. You are encouraged to work together on the assignments, but simply discuss the answers. Don't share them. Now, as far as this course is concerned, here's what we're going to be covering. First, we're going to make you comfortable with complex numbers. You should be as comfortable with complex numbers in 2 weeks as you are with real numbers as you know them today. We will then learn about vector spaces, scalar multiplication, and vector addition. We will then look at the idea of subspaces of a given vector space. From here, we will calculate the length of vectors and calculate the angle between vectors, that is, using the inner product, or as you may have seen it, the dot product. We will describe linear combinations of vectors and look at solving systems of linear equations. We'll then take a quick digression to three-dimensional vector spaces and the cross product. Now, this is the foundation of vectors and vector spaces, and this should take us to about the midterm. The rest of the course takes from here and looks at matrices and linear mappings between vector spaces. We'll describe finding the inverse of a matrix. We will then see how we can factor a matrix, the same way that we can factor a polynomial. You can write a quadratic polynomial as a product of two linear polynomials. Similarly, we will take a single matrix and see that we can write this as a product of three matrices that have very specific properties. We will then describe something called the determinant and the trace, and then introduce the adjoint of a matrix and isometric matrices. Finally, we will conclude the course by the most important concept in this course, and that is eigenvalues and eigenvectors. Basically, these are the tools that we will use to describe matrices succinctly. That is, eigenvalues and eigenvectors will tell you how matrices work. Now, again, remember, all the material that you can download on this course is on the course website and in a course textbook that you can download for free. All the lectures in this course will be on YouTube and will be linked to from the lecture materials website. And, of course, all these videos will be online after this course as well. On the lecture materials slide, there's also a primer for vectors. Some of you come from provinces or states that do not cover vectors in secondary school. The primer on vectors gives you sufficient information that you need to learn this course. Additionally, there are some YouTube videos that support this as well. There's also a very fun link called Trigonometry Made Somewhat Easier. It actually explains what the tangent of an angle is and what the secant and cosecant are geometrically, not just by definition. And then there's a fun one on how large is a coulomb. But since you're not in Waterloo, it may not make as much sense. Now, this course has no in-person lectures. You're expected to view the lecture material yourself online, and you will need to keep up with these lectures to do the assignments. I will be using the lectures to be available on WebEx during the scheduled hours for both the lecture materials and the tutorials. And you can see me here at this website. Now, one thing that's very important is that each lecture on YouTube has a number. That number corresponds to a section in the course textbook, the one that you can download for free online. Each section in the course textbook has a number of questions, and every second question has an answer. So you are expected to do these questions on your own and to ask for help from your peers, the teaching assistants, or myself if you have any difficulties. So please Remember to do this. I am not going to tell you what you have to do in these questions. Instead, it's up to you to go to the end and say, oh, okay, yeah, I know how to do this. Or, I'm not sure how to do this. Maybe work out a problem or two and check your answers with the answers that are provided. This will help you learn and reinforce the course material as you watch them on YouTube. Now, one thing that you have to remember is your brain has short-term memory and long-term memory. In your short-term memory, you can remember maybe 10 to 12 unique or distinct ideas at once. And these are going to be very short ideas. Information is only occasionally transferred from short-term memory into long-term memory. And not everything is transferred to that long-term memory. The way your brain works is only that information that it understands is important is transferred to long-term memory. Basically, something that you see over and over again ultimately gets transferred from short-term to long-term memory. Now, in secondary school, your teachers did this by repeatedly exposing you to the same material. In grade 9, you first reviewed all the material that you saw in grade 8. You then did those learned that material in grade 9. When you need that material again in grade 10, chances are the teacher went over that material a second time. And perhaps in grade 12, they reviewed it again if you needed to see it again for the first time in a while. They also had you do lots of assignments. In university, and once you get into the working world, you're going to have to do this entirely on your own. Please remember that courses in undergrad that are meant to replace courses in high school generally cover the same material in only 3 or 4 weeks with only 3 hours of lecture a week. That is, every course you see in secondary school can be taught very succinctly in only 9 to 12 hours. In university, you're going to get a lot more information in every hour of lecture, and that is going to be much more difficult if you simply rely on the learning habits you may have seen in secondary school. And you're going to discover this right before the midterm. So please help each other, but do not share your solutions. It's a Policy 71 violation if you transmit your solutions to another student, either in writing, as a picture, as a text message, or even verbally, or if you submit another student's work as your own. Now, what does it mean to transmit your solutions verbally? Basically, discuss the solutions with your peers, especially if they need help, but don't dictate the solution. Discuss it and then have each student do the work on their own. So again, help each other, work together, discuss the assignments, but in the end, do the questions yourself. So, following this brief introduction, you have an idea as to what this course will cover. You sort of know what will be expected. You can see that on the course website. You know where to find the course material, and I'll see you on WebEx. Here's the references, acknowledgements, the colophon, and a disclaimer. Cheers!